How do you calculate Rankine cycle thermal efficiency? Imagine you are watching a steam-powered machine in action, and you wonder how efficiently it turns heat into work. That's where understanding the thermal efficiency of a Rankine cycle comes in. The Rankine cycle is a common way to generate electricity using steam. To find out how well it works, you need to measure how much of the heat energy gets converted into useful work. First, you look at the work done by the turbine. This is the energy produced when steam expands and spins the turbine blades. Next, you check the work used by the pump. The pump pushes water into the boiler and consumes some energy, but this amount is usually small compared to the turbine's work. Then, you find the heat input, which is the energy added in the boiler. This is calculated from the change in enthalpy, a property that tells us how much energy the water or steam has before and after heating. Once you have these numbers, you subtract the pump work from the turbine work to get the net work output. This is the actual useful energy the cycle produces. To find the thermal efficiency, you divide this net work by the heat input. The formula looks like this: the net work divided by the heat added in the boiler. For example, if the turbine produces 100 megawatts of power, the pump uses 5 megawatts, and the heat input is 200 megawatts, then the efficiency is calculated as 100 minus 5 divided by 200, which equals 0.475 or 47.5%. This means nearly half of the heat energy supplied is turned into useful work. The efficiency of a Rankine cycle depends on the temperature and pressure at which it operates. Higher pressures and temperatures in the boiler usually improve efficiency because they increase the temperature difference between the heat source and sink. But there are limits because of the materials used and how water changes phases from liquid to steam. So, to sum up, calculating the thermal efficiency of a Rankine cycle involves measuring the work produced by the turbine, the work used by the pump, and the heat added in the boiler. Then, you apply the ratio of net work to heat input. This simple calculation helps engineers see how effectively the cycle converts heat into mechanical energy, guiding improvements in power plant design and operation.